Is the board visible? I hope the board is visible, everyone.
Yes, I do.
Right. So we are left out with some questions. We will quickly complete that questions and we'll start work, energy, and power. Okay. So let us see this question again. We are left out with around 20 odd questions, guys. So let us hope to complete them in 1 hour or 1.5 hour, and then we'll move on to work, energy, power. I'll try to give the review of work, energy, power today. All the questions of work, energy, power will solve tomorrow, right? And tomorrow we'll be doing. Tomorrow is Thursday, I guess. Work, energy, power will be done by tomorrow. System of particles will be done on Friday and Saturday, right? A small change in test I will do, guys. I think we have. Okay, I thought of conducting work, energy, power, system of particles as one test, then gravitation and units and measurement as the other test. So let us see how we can plan. If possible, I'll try to club all those four chapters and conduct a test. Okay, so till units and measurement, I'll try to complete by Sunday, guys. Okay, so that the rest of the part, modern physics and heat, those we can focus in the last week. Okay, right. So let us quickly begin the questions, guys. A block of mass 5 kg is resting, or let us come from the back. Okay, so that we can complete them. Right. So let us just come from the back, guys. Right. A graph is drawn between force acting and time for which it acts on the particle. The area covered under the curve. What will it give, beta? Area covered under force versus time graph with time axis is going to give us impulse. Impulse is nothing but change in momentum, as you are already aware. So it is going to give us change in linear momentum, guys. Right? In the same manner, let us move on to the next question. So they have given us a car of mass 900 kg negotiates a banked curve of radius 90 meters on a frictionless road, it seems. Right? Frictionless road, angle of banking is given as 45, the optimum speed. I have seen, we have discussed this yesterday, guys. 3 cases we have seen. So what is the optimum speed on a frictionless road? It will be given as root over, just a second. So what is the optimum speed on a frictionless surface, guys? It is given as root over rg into tan theta, which we have already discussed yesterday. So r value is given as 90, g value you can take it as 10, right? What is tan theta value here? You can take it as tan 45. Tan 45 happens to be 1, which you will get it as root over 900, which is 30 meter per second. So the optimum speed or the maximum speed should be 30 meter per second, guys, right? 3 cases we have discussed. What is the speed again on a banked road? It is given as rg into mu plus tan theta divided by 1 minus mu into tan theta. Yes or no? If you take a level road, then it will be root over mu rg. If you take a frictionless banked road, then it will be root over rg tan theta. These all 3 cases we have discussed in the yesterday session, guys. Let us move on to the next question. Block of mass 4 kg, right, is placed on a rough horizontal surface with coefficient of friction 0.5. A time-dependent force 4.9 t square acts on a block. At what time from the instant of applied force the block just tends to move? Okay, so what we are taking here? So let us imagine we have taken a rough horizontal surface and a certain block has been placed on it, guys. A block of mass 4 kg has been placed on it. So what will happen? First and foremost, will weight be acting vertically downwards or not? The weight will be 4 times of 10, which you will get it as 40 Newton. The weight is acting on the ground. Will ground keep quiet? Certainly not. It is going to give back a reaction. So from this point, normal reaction will be acting like this. Let us say a time dependent force has been applied along positive x direction. Now because of this force, what is going to happen? Because of this force, what is going to happen, beta? The tendency of the block to move will be towards right. So relative to the floor, the block will move to the right. Now, because it is a surface which is rough, so automatically friction is going to act in backward direction, right? When will block tend to move? Very important logic that you should remember, guys. Block tends to move when? Block tends to move if the applied force is equal to maximum value of static friction, guys. So how much is the applied force over here? The applied force, we got it as 4.9 t square. And what is the maximum value of static friction? It will be always mu times of normal reaction. Now, when you are applying force along positive x direction, will the object move in vertical direction? No. So here what we can write? Normal reaction will be equal to weight, guys. So what we can write here? 4.9 into t square. Mu value is anyhow 1 by 2 you can write. Normal reaction will be m into g. G value is taken as 9.8 here. What will you get t square value as? 4 into 9.8 divided by 2 into 4.9. So you will get 4.9 ones, 4.9 twos, 2 and 2 will get cancelled out. T square value will be 4. So after what time will it tend to move, guys? From 2 seconds, it will tend to move. Clear, all of you? Just a second. Am I audible, everyone? Yes or no?
Yes, sir.
Was there any disturbance prior before?
No, sir.
No? Okay. Okay. Because I thought the fan speed is very much high, so I have reduced it. Any doubt in this? When will block not move? Block will not move if the applied force is less than or equal to maximum value of static friction. Block will tend to move if the applied force is equal to maximum value of static friction. Block moves when applied force is more than the maximum value of static friction. Is that clear, all of you? Understood, everyone? I hope it is clear, guys. Right. So they are asking which of the following, column 1 is matched with column 2. The incorrect match of the following they are saying. Right. Now, what is limiting friction, guys? Limiting friction will always be the maximum value of static friction, guys. Okay. What is coefficient of kinetic friction? Let us see. Dynamic friction they are saying. So A is given with P. In the following question, column 1 is matched with column 2. The incorrect match of columns is static friction is less than limiting friction. Yes, because static friction is self-adjusting force, guys. It will be less than or equal to maximum value of static friction. And this maximum value of static friction is called as limiting friction. It is called as limiting friction. Maximum value of static friction is called as limiting friction, guys. Okay. Coefficient of kinetic friction is less than coefficient of static friction. Yes, this is also generally true. Static friction is less than limiting friction. It is also true. Dynamic friction is independent of contact area. When I say contact area, we are talking about macroscopic area, guys. Limiting friction, is it equal to maximum value of kinetic friction? No, guys. It is maximum value of static friction. So which will be wrong? BQ will be wrong, guys. Clear, everyone? Is that clear, all of you? Hope it is clear. Now, this is very important question where it is also a question related to your rotational motion also, guys. When a bicycle is in motion and pedaled, the force of friction is exerted by the ground on two wheels is such that. Now, if you talk about the front tire, guys, right? When we talk about front tire, so we have two tires here. You can consider we have a back tire, and in the same manner, where did it go? जस्ट अ सेकंड गाइस. अरे 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 क्या हो गया? Is it visible, everyone? Is it visible, all of you? Are yes or no, yaar?
Yes, sir.
Yes, sir.
Right. So let us try to see. We have front tire and we have back tire, something in this manner. Okay. Now, when we pedal the cycle, guys, the paddles are connected to which tire? Are they going to be connected to back tire? Yes. Will they be connected to front tire? No. So always remember, front tire will only translate, guys. Very important case. Front tire will only translate. It will not rotate, guys. You're not rotating it. It will simply translate, right? Whereas if you talk about the back tire, it will be rotating, guys. It is going to rotate again. Front tire will translate, back tire when you are paddling it, right? What is the situation here? What you are going to do? You're going to paddle it. Let us say we are paddling it in clockwise sense. So this particular back tire will have tendency to rotate, guys, with some angular speed omega. Okay. Now whenever object is rotating, due to the effect of rotation, there will be some translation effect. How will you write down the translation effect? Along the sense of rotation at the given point, it is going to be r omega. So what will happen to this point? This point, which is in contact with the ground, will try to slip in backward direction. Whereas if you take this particular point, it will try to slip in forward direction. So if you take a rough surface again, this point is slipping in forward direction. So how will friction act at this point? Friction is going to act in backward direction. Similarly, this point is slipping in backward direction. How will friction act? Friction always opposes relative motion, guys. So it is going to act in forward direction on the rear wheel and in backward direction on the front wheel. It's a very, very important. While you pedal, guys, pedal is connected to back tire. It is not connected to front tire, guys. The front tire will undergo translation. Back tire will undergo rotation. So due to the effect of rotation, every point will rotate with same angular speed. But what will be different? Linear speed will be different. If you talk about this point, right? So this point is going to rotate in which sense, beta? In anti-clock. This point, every point will rotate with same angular speed, but how will you find linear speed again? Along the sense of rotation at the given point, you're just going to draw a tangent. Okay. So if you see on the front tire, the point of contact will slip in forward direction. If you see the back tire, it will slip in backward direction. So how will friction act? Friction always acts in such a way that it opposes relative motion, guys. Clear, everyone? Is that clear to all of you? Yes or no, yaar?
Yes, sir.
Let us talk about the next question. Explosion blows a rock of mass 500 kgs into three pieces. Two pieces with masses 200 kg and 100 kg go off at right angles to each other with speed 8 meter. Yesterday, while I was discussing this concept, I've told you guys definitely such type of questions will be asked. Right. So an explosion is blowing up a rock of mass 500 kgs into three pieces. Two pieces of masses 200 kg and 100 kg go off at right angles to each other with speed 8 meter per second, 12 meter per second. What is the speed of the third part they are saying? So how will you solve for this question, guys? If you take initially this heavier object whose mass is capital M, it is breaking into two parts. Initially, is it at rest or not? Explosion blows a rock of mass 500 kg into three pieces. Initially, it is at rest. So initial speed is how much? Zero. The initial momentum will also be zero, right? So it is exploding by itself, let us say, guys. There is no there is no external force, let us imagine. So you have three masses now. One will be 200 mass, other will be 100 mass, and the other one will also be 200 mass. Yes or no? You can take this is small m, and m dash, guys. You can take these to be small m as well as m dash. So small m is 200, m dash will be 100, guys. Just a second. Am I audible? Disturbance. Actually, meeting was going on, guys, but still, I just ignored that meeting and I've just tried to continue the class. Still, okay. Now I think it is completed. The explosion blows a rock of mass 500 kgs into three pieces. Two pieces with masses 200 kg and 100 kg. Such type of question was asked 3 times in NEET examination, guys. Right? So let us say 200 kg. Now, two masses are moving with what speed? They are moving in perpendicular direction. Let us say 200 is moving with 8 meter per second along positive x direction. Automatically 100 will be moving along which direction, beta? Positive y direction or negative y direction you can consider. Initially, is there any momentum? So as you can see, initial momentum is how much? 0. So whether you take initial momentum in x direction or you take initial momentum in y direction, in both the cases it is 0. Now, as the net external force, let us say the rock is exploding by itself. As the net external force is 0, nothing has been mentioned regarding force, guys. So what we can consider? Momentum will remain constant, right? It means final momentum should be equal to initial momentum. How much is initial momentum, beta? 0. The final momentum should also be 0. What do I mean by final momentum should be 0? Final momentum you take along x direction should be 0. Final momentum you take along y direction should also be 0. So initially there is no momentum. Let us say in x direction, is there any momentum, beta? You see, yes, there is momentum along x direction. But should there be any momentum? No. So in order to cancel out the momentum due to this 200 kg mass, the other 200 kg mass will move along negative x direction. After explosion, is there any momentum in y direction? Yes, there is momentum in y direction. But should there be momentum? No. So in order to cancel out this momentum, there should be momentum in y direction, beta. This is Vy, something like this. So what is final momentum in x direction? You see, m mass is moving with plus 8. Yes or no? Plus again, m mass is moving along negative x direction. So I'll write it as, so I'll just make it towards a little bit more left. So I can write it as m into plus 8 plus m into minus vx should be equal to what, beta? 0. So what I can write? 8m minus m into vx should be equal to 0. M into vx you will get it as 8 into m. What we can cancel out? M and m we can cancel out. What will be the x component, beta, here? The x component again for the third mass will be 8 meter per second. In the same manner, if you talk about the y component, beta, final momentum in y direction should also be 0. If you talk about it, m dash mass has speed plus 12 in upward direction, plus m mass has speed in which direction? Downward direction. So minus Vy should also be 0. So 12 m dash minus m into Vy should be equal to what, beta? 0. I can write m into Vy will be 12 into m dash. Right. So what we can write Vy value as, if we talk about Vy value, I will write it as 12 into m dash divided by m. What is m dash here? M dash value is 100. What is m, beta? It is 200. So what will I get Vy value as? I'll get it as 6 meter per second. So I got x component as 8 meter per second, y component as 6 meter per second. If they're asking us to find velocity of the third mass, so it has 8 meter per second along negative x direction, guys. Yes or no? So 8 meter per second minus I cap plus 6 meter per second minus j cap. If they're asking you to find speed, it will be magnitude of v. You can write it as under root of minus 8 square plus minus 6 square. Right, 64 and 36 will be root over 100 again. So what would be the speed of the third mass, beta? It will be moving with 10 meter per second. Clear, everyone? Did you understand all of it? It's a very important question. Previous years, 3-4 times similar type of questions have been asked, guys. Did you all understand, everyone?
Yes, sir.
Right. So initially, rock is at rest. So what is going to happen? The rock is at rest. There is no momentum initially. Let us imagine rock is exploding by itself. There is no external force. Momentum should remain constant. Initially, there is no momentum. So whether you take x direction or y direction, momentum should be 0. Finally, also, momentum in x or y direction should be 0. So finally, as you can see, m mass has momentum along positive x direction. But overall, the entire system should not have any momentum. So what is the condition? The third mass should have a component of velocity along negative x direction in order to cancel out the momentum of small m mass. In the same manner, the second mass has momentum in positive y direction. So third mass should have a velocity along negative y direction in order to cancel out the momentum of the second mass m dash, guys. Clear all of you? So just by equating the final momentums to 0, we will get the x component and y component of the third mass, and it will be moving with some speed in this manner, guys. So you can say it is going to move with a speed v, which is equal to 10 meter per second. Understood all of you? Yes or no? I hope it is clear. Uh, there is some space constraint there. Right. Let us see this question, guys. A block of mass 5 kg is resting on a rough surface. What force, when a force 60 Newton is applied, the acceleration they are asking. How will you solve for this question again? Very simple logic, guys. We will just draw free body diagram. What are the forces acting? First and foremost, weight will act. What is weight here? It will be 5 into 10, which is 50 Newton. Where is weight acting? On the ground. Will ground keep quiet? No. What is it going to do? It is going to give normal reaction. The force has been applied. Let us say with horizontal, it has been applied by making an angle how much beta? By making an angle 37 degrees. So can I resolve this force into two components or not? Yes, we can resolve this force into two components. I'll get this component as F cos 37, and I'm going to get this component as F sine 37. Right. So what are we going to get? It is placed on a rough surface, guys. So because of F cos 37, as you can see, let us imagine there is no motion in y direction, guys. If there is no motion in y direction, what we can consider? Normal reaction plus F sine 37 should be equal to weight here. So I can find normal reaction from this. 60 into sine 37 value is 3 by 5. Weight value is how much beta? 50. So n plus what will I get? 36, I think, because 5 12s are 12 3 36 will be equal to 50. What will be normal reaction beta? You'll get it as 14 Newton. Now, this is an unbalanced force. So because of this unbalanced force, the tendency of the block to move will be towards right, guys. So what will happen? Friction is going to act in which direction? Backward direction. So suppose if acceleration is there, let us imagine it is accelerating along positive x direction. So what we can write net force value as beta? Net force I can write it as F cos 37 minus kinetic friction. Net force can be written as again mass times of acceleration. F value is 60, cos 37, you know it is 4 by 5. Kinetic friction value will be mu k times of normal reaction beta. So m is 5 anyhow, 5a will be equal to, you will get 48 again, minus mu k value is 1 by 2 into 14. Right, so 5a value will be 48 minus 7. 5a value will get it as 41. So what will acceleration be beta? You'll get it as 8.2 meter per second square. Clear everyone? Very simple, guys. Laws of motion is very simple again. Right? People will face difficulty in this, but why do they face difficulties? Either they have not been taught properly or they have not studied properly. Right? If they are taught properly, obviously they'll study properly. Right? So basic logic is this: whenever laws of motion questions are there, identify the forces, draw the free body diagrams. If there are any unbalanced force, net force will be mass times of acceleration. As simple as that. Okay. Let us talk about the next question. A shell of mass 2 kg is fired from a gun of mass 40 kg. If the speed of the shell is 200 meter, then recoil speed of the gun. So initially, if I take, the gun is taken something in this manner. Initially, the gun and the bullet, they are inside. So they are not moving, guys. Okay. So initial momentum is 0. Finally, also, when you are firing it, everything is happening inside only, guys. This is one particular system again. So as you fire the gun, it is internal force again, right? It is not an external force. So internal forces will not affect the motion again. So as it is fired, initial momentum is 0 because the bullet is there inside the gun. Gun is not being fired, so they are not moving at all. So initial momentum is 0. Are we applying any external force? When gun is being fired, it is because of internal force, guys. It is inside the system again. So So there is no external force over here. So as there is no external force, what is going to happen? Momentum will remain conserved. Momentum will remain conserved, guys. Let us see. If you are firing the bullet is moving with speed u. Now momentum is there along x direction. Initial momentum is 0. Now momentum is there along x direction. But should there be momentum in x direction? No. So in order to cancel out this momentum, what will happen, beta? Bullet is going to recoil with speed v. So how much is initial momentum? Initial momentum is 0. As net external force, again, is there any external force? When you are firing the gun, it is inside the system, guys. So as net external force is 0, what we can say? Momentum should remain constant. What do I mean by momentum should remain constant, beta? The final momentum should be equal to initial momentum. How much is initial momentum already? 0. So final momentum should also be 0. Finally, if you write momentum, you will get m into plus u plus capital M into minus v should be equal to what, beta? 0. So I can write mu minus m into v will be equal to 0. M into v will be equal to small m into u. What is the recoil speed? Small m divided by capital M into u. If you just substitute the values, guys, small m is given as 2 kg divided by the gun is given as 40, the speed is given as 200. So what will be the recoil speed? I think 10 meter per second should be the recoil speed. Is that clear, everyone? Basic example of conservation of linear momentum, guys. Understood, all of you? I hope you have. Then let us try to see this case. Position time graph of a body of mass 3 kg is shown. Magnitude of impulse acting on the object at t is equal to 3 seconds here. What do I mean by impulse, guys? Whenever we talk about something called as impulse, impulse is nothing but change in momentum. What is change in momentum? We know momentum can be written as mass times of velocity. So I can write it, if mass is constant, I can write m into delta v, which is m into v final minus v initial. Which graph is given? Position time graph is given. From position time graph, what we can obtain, beta? Slope of position time graph will give us velocity. You see, just before 3 seconds, this is the slope. Just after 3 seconds, this is the slope. It means at 3 seconds, there is a change in velocity. So whenever there is change in velocity, obviously there will be some impulse, guys. Okay. So what would be the situation if I talk about before, just before 3 seconds? Initial velocity if I take, will it be slope of this or not, guys? So what is this point? You can write it as 3 comma 12. This point is how much? 0 comma 0. So what is the slope here? I can write 12 minus 0 divided by 3 minus 0, which you will get it as 12 by 3, 4 meter per second, let us say along positive x direction. Now what is final velocity, beta? Finally means just after 3 seconds. If you talk about 3 seconds, it is a straight line. So what will be slope of straight line? 0. So what is the impulse that I am going to get here? Mass is how much? 3 kg. What is final velocity? 0 minus initial velocity 4 I cap, beta. So what will be the impulse that I am going to get? I am going to get it as minus 12 I cap. Implies the magnitude of impulse if I take, it will be 12 kg meter per second. Understood, everyone? At whichever point you have a change in velocity, at that point you will have change in momentum. Whenever there is change in momentum, obviously there will be some impulse associated. So as you can see, from 0 to 3 seconds, velocity will remain constant because slope of position time graph is constant. After 3 seconds, again velocity will remain constant, which is 0. So here velocity has some value. Here velocity has some value. So where is it changing? It is changing at 3 seconds, guys. So at 3 seconds, there is some impulse being applied. Clear, everyone? Yes or no? Is that clear, all of you? Hope it is clear. Let us move on to the next question, guys. Pull of 80 Newton is applied in the direction as shown. A constant frictional force of 30 Newton is opposing the motion. The mass of the block. Again, is it similar type of question just we have done or not? Did we just now do it? Similar type of question. So can you solve for it, guys? Yes or no? Okay, that's not a problem. If we can solve once again, also it's not a big deal, guys. So you have a 5 kg block here. What are the forces that are going to act? first and foremost, weight will be acting in vertically downward direction. 5 into 10, you can take it as 50 Newton. Right? Where is weight acting? On the ground. Will ground keep quiet? No. What is it going to give back? It is going to give back normal reaction. Also, what force is acting, beta? 80 Newton force is applied. At what angle is it applied? It is being applied at a certain angle, 37 degrees. There also it was 37 degrees only, I believe. Yes or no, guys? Yes. So what will the force be here? If I can resolve, I'll get it as F cos 37. Cos 37 will be 4 by 5, guys. So if I just write 80 into 4 by 5, you will get it as 16 64 Newton you will get. In the same manner, here you are going to get F sine 37, which turns out to be 80 into 3 by 5, right? Which you will get it as 48 Newton, guys. And they're saying, so as you can see in vertical direction, if there is no motion, what we can write, beta? Normal reaction plus 48 should be equal to what? 50. So what will I get normal reaction as? I'll get it as 2 Newton. Okay. In the same manner, what we can also say, right? This is an unbalanced force. So because of this unbalanced force, the system will tend to accelerate along positive x direction. So relative to the floor, the block will tend to along positive x direction. So what is going to act, beta? Friction will be acting. And they are saying that a constant value 30 Newton is acting. So what we can write net force as? Here we have 64 minus 30. So I can write 5 into A value will be 24. So A value will get it as 4 point. This is 26, no? 34 you will get, no? Yes or no? You will get 34. So I'll get it as 6.8 meter per second square. Is that clear, all of you? It's a similar question that we have done just now. Yes or no? I hope you understood it, guys. Okay. Then let us try to solve the next question. The mass of hanging man is 30 kg. What is the value of tension shown? They are asking. Again, if it is in equilibrium, if we talk about concurrent forces are acting at a particular point. So what is the force acting here? Weight is going to act. If a man is hanging, so at this point, weight of the man will act, guys. So how much is that weight of the man? It is mass is 30, so I can say 300 Newton is the weight. Now imagine this to be your horizontal. Imagine this to be your vertical. Okay. Now you have two strings here, guys. So here, let us imagine in one of the string, tension is, let us take it as T dash beta. And in the other string, let us imagine the tension is taken as T. Now, as you can see, what I'll do is I'll just draw a horizontal over here. Okay. So what is the condition that I'm going to get? If this is 53, automatically this will also become 53. Automatically this will also become 37. Yes or no? Alternate interior angles we can use, guys. So how much is this angle? This angle you will get it as 53 degrees. Automatically this is 90 beta. Similarly, what is this? This is your 37 degrees. This is anyhow 90. Now you see, if this is 53, this will be 37. And if this is 37, this is 37. If this is 53, this is 53. So overall, this value, if I take, it is 90 degrees. So I can apply Lamis theorem again. So what was it state? W divided by sine of the angle opposite to it. What is this angle? This angle entirely, if I take, this will again be 90 degrees beta. Sine 90 should be equal to T divided by, what is the angle opposite to it? Sine of 90 plus 37. Yes or no? Should be equal to T dash divided by sine of, what is the angle opposite to it? 90 plus 53, guys. Okay, so what we can write? W divided by sine 90 should be equal to, what is sine 90 plus theta? 90 plus something means it is complementary, guys. Complement of sine will be cos in second quadrant, sine will be positive, so I'll get it as cos 37. Should be equal to, on the other side also I'll get it as cos 53, guys. So what will be the value of t here? I can write t value will be sine 90 anyhow is 1. So I can write it as W cos 37. So what will I get the value as? W is given as 300. Cos 37, it is 4 divided by 5. So I'll get it as 240 Newton, guys. Similarly, what we can write T dash value as? I can write it as W cos 53, right? W value is 300, cos 53 can be taken as 3 by 5, which I will get it as 180 Newton beta. So if they're asking you by applying the Lamis theorem, we can solve for the answer. Clear, everyone? Yes or no? Did you understand, all of you? Right. Let us try to see one more question. A pendulum is hanging from the ceiling of a car having a horizontal acceleration. It is also very important case, guys. Has a horizontal acceleration of 5.65 meter per second square. What is the angle made by the string with respect to the vertical? So again, it's a case of non-inertial frame of reference beta. So let us imagine we have a pendulum attached to the ceiling of the car. Okay, we have a pendulum attached to the ceiling of the car of mass m, and this particular car is accelerating with acceleration a. Okay, so what are we going to do, guys? Let us try to understand the situation with respect to the car, guys. With respect to car, does car have any acceleration? Yes. So with respect to car will be which frame of reference beta? Because it has some acceleration, it will be non-inertial frame of reference or accelerated frame of reference. So whenever we are dealing with non-inertial frame of reference, what are we going to bring into picture? We are going to bring into picture some quantity called as pseudo force, guys. So what is going to happen with respect to car means I will stop the car, and what I am going to do, whatever acceleration is there to the car, I'm just going to give it to the object in opposite direction. Will I give only acceleration? No, I'm going to multiply with its mass, right? So a force has been given. This point is fixed beta. This cannot move. Now when force is applied, so what will happen? This particular pendulum will try to, so if this is your natural position of the string, then it will try to displace in this direction and it will be attaining equilibrium somewhere over here. So what are the forces that are going to act here? Here you have a pseudo force which is given as m into a, and also if I assume, let us say mass of the pendulum happens to be a m, guys. Right. So what are the forces that are going to act? As you can see, pseudo force will act because we are solving the question with respect to car. Car has acceleration, so it will be a accelerated frame of reference or non-inertial frame of reference. The pseudo force MA will be MA will be acting, and in the same manner, what else is going to act, beta? Its weight is going to act something like this. Okay. Also because it is connected to string, right? Tension will be acting. So what will happen to this tension? This tension will be cancelled out by the resultant of MA and MG, guys. The tension will be cancelled out by the resultant of MA and MG. Let us say it has got displaced by an angle theta. So I can say this angle will be theta. So from this, what we can write? Can I apply tan theta here? So what will I get tan theta value as? I'll get it as MA divided by MG. So tan theta value, I'll get it as what, beta? A divided by G. So tan theta value can be taken as 5.65 divided by 10. So whatever it is, just check that out, how much it will be, or 9.8 also you can take if you want to, right? So it is near about 0.565, right? So tan 30 is 1 by root 3. Root 3 by 3 you will get, which will be point, yeah, near about 30 degrees, I think. 37 will be how much? 3 by 4. Yes or no? 3 by 4 will be 0.7 I will get again. Tan 37 is. So what will I get? From this situation, I can write tan theta value as 565 divided by how much, beta? 1000. Just check it how much we are getting. Can we cancel out it by, you can take it, if you take 5, you will get 200. This you will get it as 113, I believe. Am I right? Yes. So I will get tan theta value as how much here? Tan theta value, you'll get it as, again, anyhow, you will get directly, you can write. So from this, you will get tan theta value as how much beta? 0.565 you will get. So it means what will theta value be? Tan 60 is root 3. This is not going to be correct. 40 is 1, which is not going to be correct. Right? 37 if I take, you will get 37 as 3 by 4, I believe. Yes or no? 3 by 4 will be 0.75. This is also wrong, guys. So what will be the answer? 30 degrees will be the answer. Clear, everyone? Is that clear, all of you? I hope it is clear. Then, next case you see, in the system shown in the figure, a mass 30 kg is pulled by a force of 200 Newton. At the instant when its acceleration is 3 meter per second square in forward direction, what is the magnitude of 15 kg mass? See, please try to understand. Two blocks are like this. One block is being pulled along positive x direction. So as you pull one block, is spring getting elongated or not? Yes. So basic logic is you will draw the free body diagram here. So if I draw the free body diagram, what are the forces that are going to act? Let us say for 30 kg mass, I'm drawing the free body diagram. So firstly, its weight is going to act. Weight will be how much beta? 300 Newton. Weight is acting on the ground. Will ground keep quiet? Certainly not. It is going to give back a normal reaction. And what has happened? A force has been applied. How much force has been applied? 200 Newton. Now, because of this force, what is going to happen? The spring is going to get elongated. And what is the nature of spring force, guys? It will try to bring the block back to its original position. So, spring force will act in this manner. So, it has been mentioned that this whole system is accelerating along positive x direction. So, what will be the net force in this case, guys? Net force, I can write it as 200 minus spring force. So acceleration is already given, so I can write 30 into 7 will be equal to 200 minus spring force. Yes or no, all of you? So what are we going to get? Acceleration is given in this manner only, no? At the instant when its acceleration is 7 meter per second square in forward direction, what is the magnitude of acceleration of 15 kg mass they are saying? Or anyhow, if you can, so what I'll get here, 210 value will be 200 minus spring force I'm going to get. So what will spring force value be? You are getting minus 10. It is wrong, no? In the system shown in the figure, the mass 30 kg is pulled by a force 200 Newton. At the instant when its acceleration is 7 meter per second square in forward direction, what is the magnitude of acceleration of 15 kg mass they are asking? So obviously spring force should be less, no, here. Okay. Okay, let us just do it, but I don't think we'll get correct answer for this. If I take 15 kg block, what will be the force that will act? Again, its weight is going to act in downward direction, which is 150 Newton. Right? Likewise, weight is acting on the ground. Will ground keep quiet? No. It is also going to give some normal reaction. Let us take some N dash. Okay. Now, because spring got elongated, what will it do? It is going to apply spring force in this manner. So spring force is going to give us acceleration to 15 kg block. So if I write net force in this situation, what are we going to get? If I write net force for this block, I'm going to get net force as spring force only. So net force, I'll write it as mass times of acceleration. How much is the mass here? Mass is 15 into A dash. Will be, we got 10. Implies A dash value will be 10 divided by 15, which I'll get it as 2 by 3, which is 0.67 meter per second square. But it will be along negative x direction, guys. Okay. Because we got spring force is minus. If we are getting spring force is minus, it means the spring force is acting along positive x direction. Whatever direction of spring force we have taken, it will be wrong again. It means spring force is acting along positive x direction. So on this block, it is trying to separate the blocks back. So 15 kg block will accelerate along negative x direction. Although, right, if we go by the concepts of physics, this question is wrong, guys. Clear, all of you? Understood or not? See, because if it is accelerating along positive x direction, it means that net force should be there along positive x direction. Right. So if you write that 200 minus spring force, I will get it as 30 into 7, guys. Yes or no? Did I write all the cases correctly? 37 is 210 only, no? Yes. So this will be wrong again. This cannot be true again. This question itself will be wrong, guys. Clear, all of you? Understood? Am I audible, everyone?
Yes, sir.
Right. So you cannot get spring force as minus 10 Newton over here. Okay, which is wrong. Clear? However, we can take it something like this. Let us say spring force is acting in this direction. But once you are pulling the block, obviously spring is going to get elongated, guys. So I'll take this as plus. I'll take this as plus. I'll take this as plus. Then I'll get plus 10 Newton. Now I can say if spring force on 30 kg is acting like this, then automatically spring force on 15 kg will act like this. When will spring force act in this manner, guys? If the blocks are compressed again. So now I can say acceleration will be 0.67 meter per second square. But although, right, if you look at the concept, by the concepts of physics, this question is wrong, guys. Understood, everyone? When a horse pulls a wagon, the force that causes the horse to move forward is which force, guys? Obviously, when horse is pulling a wagon, who is going to exert a force? When horse is pulling a wagon, right, the force that causes the horse to move forward is which force they are saying. So while he tries to pull the wagon, the force will apply some force on the horse will apply some force on the ground or not? Yes. So obviously, what should be the answer? The ground which exerts the force on horse will make it to move it forward. Clear, everyone? Yes or no? Next.
So can we consider weight as a force exerted by the horse on the ground?
Wait, आराम से बोलो.
So can we consider weight as a force exerted by horse on the ground?
Weight as the
Weight as one of the force exerted by horse on the ground.
weight to will definitely add, but weight is weight is applied by earth again, but horse will apply some other force. It cannot apply weight. Okay, earth is going to apply weight again.
Clear.
A block is placed on a rough horizontal surface. The frictional force acting on the block. See, block is placed, it seems. Is the block at rest or not? So what are the forces that are going to act? If you look at this, weight will act, which is 50 Newton. It is acting on the ground. Will ground keep quiet? Certainly not. It is going to give normal reaction in this manner. So vertically, there will not be any motion, guys. So I can say normal reaction will be equal to weight, which is 50 Newton. But is there any force which is making the block to move? No. So there is no applied force at all. So if there is no applied force, is there necessity of friction? No necessity of friction, guys. So how much will be the friction in this case? 0. Whenever object is at rest, static friction will act. And static friction happens to be a self-adjusting force, guys. Because there is no applied force. Again, there is no necessity to counter. There is no necessity for the surface to counter. Because you're not even applying the force. Yes or no? However, what is the maximum value of static friction that is going to act? It will be mu s times of normal reaction, which is 0.5 into 50, right? Which will get it as 25 Newton. But don't say that 25 Newton is the answer, beta. This is the maximum value of static friction that will act. But here in this case, frictional force acting will not be 25 Newton, right? Because you don't have any applied force, there is no necessity of friction to act. The friction acting will be 0 in this particular case. Clear, everyone? Or no, static friction is a self-adjusting force, guys. It will vary depending on the force applied. Next question, let us see. A block of mass 1 kg is horizontally thrown with velocity 10 meter per second on a stationary long rough plank whose coefficient of friction is. Again, a very basic logic. Let us imagine we have a certain plank or a certain rough surface in this manner. What we are doing, we are taking a block and we are throwing it, guys. Let us say t is equal to 0. We have thrown it with some speed, right? With a speed of 10 meter per second. Now, because it is a rough plank, relative to the block will be moving along positive x direction. So what is going to act, beta? friction is going to act in backward direction. What are the other forces that will be acting? Its weight is going to act mg. Where is it acting? On the ground. Will ground keep quiet? Certainly not. It is going to give back a normal reaction. So while you are throwing horizontally, will the block move in vertical direction? No. So what I can write? Normal reaction will be equal to weight, which you will get it as 10 Newton beta. Now, as you can see, friction is an unbalanced force. Always remember, in the direction of unbalanced force, we are going to have net force. In the direction of net force, we are going to have acceleration. In this case, velocity and acceleration are acting opposite to each other. So when velocity and acceleration act opposite to each other, what is going to happen? Object will move in the direction of velocity with decreasing speed till its velocity becomes 0. If this is the situation at t is equal to 0, it is going to come back to rest after t seconds, guys. So what I can apply now, what is the value of friction that is going to act? Friction value will be mu times of normal reaction, or kinetic friction will be mu k times of normal reaction, which is 0.25 into 10 beta. How much friction will be acting? 2.5 Newton. So in that direction only we are going to have acceleration. What will that acceleration be? It will be net force divided by the mass, which again I'll get it as 2.5 meter per second square. So we know the velocity, initial velocity, you know the final velocity, you know the acceleration, which is constant value. So directly I can apply v bar is equal to u bar plus a bar into t. Final velocity is anyhow 0. Initial velocity along positive x direction, so plus 10. What is acceleration beta? Minus 2.5 into t. So I can write it as 10 minus 2.5 into t. 2.5 into t can be taken as 10. So after what time will the block come to rest beta? It is going to come to rest after 4 seconds. Very basic question of you can consider retardation motion, guys. Understood, all of you? Yes or no? I hope it is clear, everyone. Here friction is an unbalanced force. So friction will give us net force. In the direction of friction, we are going to have acceleration. Because the acceleration is opposite to the direction of velocity, it will be called as retardation. And whenever velocity and acceleration are in opposite direction, what will happen? Object will move in the direction of velocity with decreasing speed till its velocity becomes 0, guys. Clear, everyone? I hope it is clear. Let us talk about the next question, guys. What they have given is a man is inside a lift which goes up and comes down with same constant acceleration. If the ratio of the apparent weights in both the cases is 3:1, what is the acceleration of the lift they are saying? Right, as I said you before, guys. So if you take a lift, right, and let us imagine a man is standing inside the lift, guys. What is the meaning of apparent weight? Normal reaction will be the apparent weight, guys. So what are the forces that are going to act here? First, weight of the man will act. Where is weight of the man acting? On the ground, right? So what will happen? Ground, the lift will not keep quiet. It is going to give back a normal reaction. In first case, where is lift accelerating? Upwards. Next case, where is it accelerating? In downwards. So if I draw the free body diagram for case 1, where is the acceleration? Upwards. So how will I write net force as? In first case, I'll write it as n minus mg. So I can write m into a value will be n minus mg. N value we can write it as m into a plus m into g. So I will get normal reaction as m into g plus a, which will give us the apparent weight, guys. In second case, where is it accelerating? Downwards. So if it is accelerating downwards, what will net force equation be? It will be mg minus normal reaction, let us say n dash in this case. So what I can write with same acceleration they have given. So mg minus n dash you can write. So I'll get m dash value as mg minus m into a. So what will n dash value be? M into g minus a. What they have given, the ratios of the apparent weights. Apparent weights are nothing but the normal reaction, guys. The ratios of apparent weights are given as 3:1. So what I can write? M into g plus a divided by m into g minus a will be equal to 3:1. So I can write g plus a value will be 3g minus 3a. So 4a value will be equal to 2g. A value will be equal to g divided by 2, which I'll get it as 5 meter per second square. Clear, everyone? In general, you remember tension, whether you write, see again, tension will also give us apparent weight, guys. Normal reaction here is giving apparent weight, right? If you take a pulley block system or a pulley man system, tension will give apparent weight, guys, there. So in general, we can write normal reaction as m into g effective again. Okay, in vertical system, whenever you are taking normal reaction, we can write m into g effective. Is that clear, all of you? Yes or no? Right. Now, in this case, coefficient of friction of a rough inclined plane is 0.7. What is the tension in the connecting wire shown? They are asking, guys. So what are the forces that are going to act? See, coefficient of friction is given as 0.7. So using this, can I find out the value of angle of repose? So what will alpha value be beta here? Alpha value will be tan inverse of mu. So alpha value will be tan inverse of 0.7. 30 degrees is what? Tan 30, if I take, it is 1 by root 3. 1 by root 3, if you solve, guys, you will get it as near about 0.567. So here, theta is how much? So alpha value will be more than 30 degrees. So here, theta is given as 30 degrees. Yes or no? So what is tan 30? Tan 30, we know it is 1 by root 3, which we can write it as root 3 over 3, which is 1.732 over 3. So you will get it as 0.5, 23 will be there, 0.57, 0.577 you will get. So 30 degrees is tan inverse. So what I can write from this? I can write 30 degrees will be tan inverse of 0.577. Okay, but I have tan inverse of 0.7. Will it be more than tan inverse of 0.577 or not? So here alpha value is more than 30 degrees. So what is the situation? Whenever a block is placed on a rough inclined plane whose inclination is less than angle of repose, will it remain at rest or not? Yes, obviously it is going to remain at rest. So if I draw the free body diagram, what are the forces that are going to act here? One component of weight will act, which is mg cos 30, right? Other component of weight will act, which is mg sin 30. Is the block going to remain at rest? Obviously it will remain at rest, guys, right? One normal reaction will act something in this manner. What is the other force that will act? Friction is going to act like this. Which force? Static friction, which will adjust itself. So here static friction alone will be cancelling out mg sin 30. So is there any necessity of tension to act, beta? No, there is no necessity of tension to act. So tension value here will be 0. Clear, everyone? So when will tension act, guys? If the angle of inclination is more than angle of repose. So here angle of repose is more than angle of inclination. It means you take any block and place it on the rough inclined plane, it will remain at rest only, right? So here the component mg sin 30 can be cancelled out by friction. So is there necessity of tension? No necessity, guys. Understood, all of you? If theta value is more than alpha, then tension value will be there. Understood? They're asking us this question: what force must man exert on the rope to keep platform in equilibrium? So in order to keep the platform in equilibrium, net force should be 0 or not on the platform. So what is the condition you see? If I take free body diagram of the man, what is man doing? Man is trying to pull. So he is applying some action on the rope. In which direction? Downward direction. So obviously what will rope do, guys? It is going to give a reaction in upward direction, which is this force F. Also, what is going to act? His weight is going to act, right? Let us say capital M is given. So mg is going to act. Where is it acting? On the platform. Will platform keep quiet, beta? Obviously no. What is it going to give? It is going to give a normal reaction. You can say n dash. Now what I'll do, I will draw the free body diagram of platform, beta. You see, I'm drawing the free body diagram of platform. What has happened? This particular thread has been pulled down with a force F. It means this will be pulled up with a force F, right? This also you can consider will be pulled up with a force F, right? Same thing, right? Now, if I draw free body diagram of the pulley, guys, here you have force F. Here also you have force F. So automatically here you are going to have a force 2F, guys. So what are the forces that are going to act on the plank now? Here 2F force is going to act. Also apart from that, weight of the plank mg is going to act. Now please see, what is n dash? N dash is the reaction given by the plank. Why did it give this reaction? Because the same would have acted on it as action or not. Action and reaction are equal again. N dash here is reaction given by the plank. Why did it give reaction? Because the same would have acted on it as action. It is in equilibrium again. So if it is in equilibrium, what we can do, beta? We can directly write 2F value will be equal to mg plus n dash. And here what I can write? F plus n dash value will be equal to m into g, guys. So what will n dash value be here? 2F minus mg you can consider, which we can substitute here. So I'll get F plus 2F minus mg will be equal to capital Mg, beta. So what I'll get? 3F minus mg will be equal to capital Mg. 3F value I can write it as small mg plus capital Mg. So what is the force that we are going to apply? Small m plus capital M into g divided by 3, which turns out to be 40 plus 50 into 10 divided by 3, which is 900 over 3. I'm going to get it as 300 Newton. Did you understand the free body diagram? Equilibrium means what, beta? Net force has to be 0. What are the forces? Very important case. In order to keep the system in equilibrium, man is trying to pull the rope downwards. So what is the action given by man? He applied a force F in downward direction. The rope will automatically give a reaction where in upward direction. His weight is acting on the plank, right? So that weight will act on the plank. So there is some action given by the man on the plank. So what will happen? Plank will give out a reaction. Planck gave this reaction. It means the same would have acted on it as action or not. Yes. And I've used pulley constraints here. So if you take massless pulley again, right, net force on the pulley should be 0. Here you have F and F. So automatically the plank will be pulled up by force 2F. Understood all of you free body diagram? Did you all understand the free body diagram? I hope you have, guys. Next. A ball moving with momentum of 15 kg meter per second strikes against a wall at an angle 60 degrees with the plane of the wall and reflects back with same momentum at the same angle. What is the impulse they are asking? Again, direct question, guys. We have done, I think with the case of water jet, we have done similar kind of question. So if I take something in this manner, so let us take, we have considered a ball. Let us imagine it is moving with some speed u. So it is going to strike the floor here, striking the wall they are saying, but I am just writing it as the floor here. So automatically this will be the point of incidence, and they are saying it is reflected back by making the same angle, guys, and also with the same speed, with same momentum they have said, at same angle. So here also it is projected with speed u. But what they have given is this angle is given as 60 degrees. Right, these angles are given as 60 degrees. They are asking us to find what would be the impulse acting on the ball, guys. So what we can do, we can resolve this momentum into two components, right? So you can take it something like this. So if this is 60, automatically this will also be 60. If this is 60, automatically this will also be 60. If you resolve into two components, what will I get? Here you will get u cos 60. Here also I'll get u cos 60. Is this component of velocity responsible for collision? No. This component of velocity is not responsible for collision, guys. So momentum along x direction will remain conserved. What is changing? Momentum in y direction will change. Here you have u sine 60. Here also you are going to have u sine 60 in upward direction. You see, momentum has changed in which direction? in y direction. So what is the impulse acting on the ball? It will be change in momentum of the ball. And where is momentum changing? It is changing only in y direction. So what I can write? I can write final momentum of the ball in y direction minus initial momentum of the ball in y direction, guys. Is that clear, all of you? What is final momentum? As you can see, m into u sine 60. In which direction it has? J cap. Initial momentum in y direction, m into u sine 60. In which direction, beta? Minus j cap. Minus into minus will become plus. You will get it as 2mu sine 60 j cap, which I can write it as mass is given as 15. Sorry, mass is not given, no? Did they give a ball moving with momentum of? Achha, momentum is given, no? Anyhow. So what is m into u, beta? It is nothing but momentum, which I can write it as 15. Sine 60 we can take it as root 3 by 2 j cap. So I'll get the answer as 15 root 3 j cap. This will be the momentum acting on the ball. Who has applied this momentum? Sorry, this is the impulse acting on the ball. Who has applied this impulse? Obviously, the floor or the wall will be applying this impulse. Clear, everyone? Yes or no? Hope it is clear. It is also important question, guys. Change in momentum. Again, impulse questions are very important. Let's see the next part. A lift starts from rest with constant upward acceleration. It moves first 4 meters in 5 seconds. A man in lift holds a packet of mass 2 kg by a string. The tension in the string during the motion they are saying. Okay. Again, very simple logic, guys. Lift start from rest. It is moving upwards with constant acceleration they have given. Yes or no? So lift starts with rest with constant upward acceleration. It moves first 4 meters in 5 seconds, it seems. So a man in lift holds a packet of mass 2 kg with the help of a string. Tension in this string they are asking, guys. So what I can do, instead of man, drawing man and all, what I'll assume, there is a certain, we can consider there is a certain packet hanging from the ceiling. Mass of the packet happens to be 2 kg, guys. Now, where is it moving? It is moving upwards with an acceleration a. They're asking us to find what is the tension, guys. So what is given? It is initially starting at rest they have given. So can I apply constant acceleration they have given, guys? So can I apply S bar will be u bar t plus half a bar t square? Yes. So what I will get? 4 will be equal to initial velocity 0. Half into acceleration t square is 5 square you can write. So what will our acceleration be? 4 value will be 25 a by 2. So what will our acceleration be, beta? 8 by 25 meter per second square you will get. This is our acceleration. Yes or no? Now you see they're asking tension. So what are the forces that are going to act on the block? First of all, its weight will be acting mg in downward direction. Its weight is going to act mg in downward direction. What is the other force that will be acting? Tension will act. Now, if the lift is accelerating, the man inside the lift will accelerate, and whatever he is holding also will accelerate. So it means this particular block is going to accelerate in which direction? Upward direction. So what would be the net force in this case, beta? Net force, I'll write it as tension minus mg. So m into a value will be tension minus mg. So I can write tension as mg plus m into a, which can be taken as m into g plus a, which can be taken as, what is mass here? 2 kg. G is anyhow 9.8, or you take it as approximately 10, guys. That's not a big deal. You can take it as 10 plus 8 by 25 you will get. What is 8 by 25 if I take into 100 by 100? If you do, you will get 25 ones force into 100 by 100, 32.32 you will get, I guess. Yes or no? So this you can take it as 9.8, and a value I'll get it as 0.32 beta, which will be 2 into, how much will this turn out to be? 2, 11, 10.12 I'm going to get, which turns out to be 20.24. Clear, everyone? Did you understand, all of you? Tension again will be m into g effective, we can write here. Is that clear? Yes or no? I hope it is clear, guys. Next question, if you see, what they have given is a rocket from launching pad is set for vertical lift off. The exhaust speed is 1500 meter per second. How much gas must be ejected per second to just lift off the rocket? What is the situation? To lift off the rocket, it has to counter the weight of the rocket or not? Just to lift off, they are saying. So if I take this is the rocket, what are the forces that are going to act? Its weight will be acting mg. So in order to lift, just to lift, there should be a certain force applied on the rocket. How are we going to get this force, guys? As soon as the rocket ejects some gas, the gas is going to provide some upward lift, guys. What we can write here, in order to lift the rocket, the force applied should just counter the weight, or it should be just more than weight. Okay, so what we can write? Force we can write it as you all know, we can write it as change in momentum, dp divided by dt. Mass of the rocket is given as 6000 into 10. Now, how can we write this? Momentum can be written as mass into velocity or not, which will be 6 into 10 power 4, you can write. Here, mass, what must be, how much gas must be ejected? Exhaust speed is constant again. So, if it's a variable mass problem, guys. So, V into dm by dt will be given as 6 into 10 power 4. So, what I will get dm by dt value as? I will get it as 6 into 10 power 4 divided by V. So what I'll get dm by dt as, we can take it as 6 into 10 power 4 divided by V is given as 1500 beta. So I can write it as 600 divided by 15. So you'll get it as 40 kg per second should be the rate at which the gas has to be ejected in order to just lift the rocket, guys. Understood, all of you? Yes or no? I hope it is clear. Now, next question. They are asking the block has uniform mass density. It's a uniform rope. They're asking us to find tension at the midpoint, guys. You can consider we have two forces. This is F1, this is F2. Yesterday, we have already told you the method of finding out the tension. So, what would be tension at this particular point? How much is the tension they're asking? So, how can you find the tension value, beta? Because of F1, 22 into length on the other side. What is the length on the other side? 5 by 2. Whole divided by total length 5. Plus, because of this, 6 into length on the other side. Again, 5 by 2 whole divided by total length 5. So, what are we going to get here? 22 by 2 will be 11 plus 6 by 2 will be 3, which I am going to get it as 14 Newton. Very direct question, guys. Understood, all of you? Yes or no, everyone? I hope you have understood it. Next, let us see this question. A train takes round turn on a banked bend of radius 300 meters at a speed of 20 meter per second. The mass of the train is 10 power 6 kg. The spacing between the rails is given as 1.5 meters. Through what height outer rail be raised with respect to the inner surface for safe turning of the train, they are asking. So here we need to find the angle of banking, guys. How will you find the angle of banking? We have basic concept again. The maximum speed on banked road again. On a banked road, they have not given anything related to friction, guys. So what would be the maximum safe speed? Root over Rg tan theta we have. So what we can write? 20 will be equal to root over 300 into 10 into tan theta we will get. If you square it on both sides, what will I get? 400 value will be 3 into 10 cube into tan theta. Right? So what will I get from this? Cube will get cancelled out. 2 squares will be cancelled out. I'll get 4 divided by 30 will be equal to tan theta. So I can write tan theta value as 2 divided by 15, guys. This is the situation. And we know for small angles, tan theta will always be equal to sin theta, and tan theta will be approximately equal. So here in this situation, what do we have? One rail is here. Let us imagine this is the horizontal. Other rail is somewhere over here, guys. Okay. So this is the distance between the rails. And this is the height by which the outer rail has been inclined. Right. So what is the value given? This is our angle of banking. What is given to us? D is given to us. So for small angles, we can take tan theta will be approximately equal to, or sin theta will be approximately equal to tan theta. So for small angles, we can write sin theta value will be approximately equal to tan theta. So what is sin theta value here? It is h by d. Should be equal to what is tan theta value? 2 divided by 15. So what will you get h value as beta? 2d by 15. D value is already given as 1.5 meters. So this will be ones and tens. So what will I get the value of h as? H value will be 0.2 meters, which will be 20 centimeters. So outer rail has to be inclined by how much angle beta? 20 centimeters. Clear all of you? Yes or no, everyone? So maximum speed on a frictionless banked road will be root over Rg tan theta. From there, we found out the value of tan theta, which is angle of banking. So for small angles, sin theta and tan theta both will be equal. So from here, we can find out the height by which the outer rail, this is your outer rail beta, and this is your inner rail. The height by which the outer rail has to be raised. Clear? Understood, everyone? I hope it is clear. We see force is acted upon, a body is acted upon by a force. Initial velocity is given. The time at which will just have velocity along x direction. So what is, if you can just compare this, guys? So can I find out what is the initial velocity in x direction? It will be equal to 6 meter per second, right? And what is the initial velocity in y direction? It is minus 12 again, I can write. Means minus indicates it is along negative y direction. Now, please tell me what is acceleration in x direction? Acceleration is nothing but force by mass, guys. So I will get it as minus 3 by 5 meter per second square. And what will be acceleration in y direction? You will get it as 4 by 5 meter per second square. Both are constant accelerations only. They're asking the time at which velocity is only along x-axis. So what I can say, can I write final velocity in y direction should become how much beta? 0. So what we can take? Initial velocity in y direction plus acceleration in y direction into t will be equal to 0. Implies you will get minus 12 plus 4 by 5 into t should be equal to 0. 4 by 5 into t, you will get it as 12. Right? I can write t value as 60 divided by 4. So after 15 seconds, right, we are going to obtain velocity only along x direction. Clear, everyone? Direct question again. I hope this question is clear to you all. Let us talk about the next concept, guys. The velocity of a body as a function of time is given. They're asking us to find out. Two questions are there. We'll quickly complete those. You can take a 5-minute break and we will start work energy power after that. The velocity is given. What force is acting on the body? So what we can write here, velocity is varying with time. So I can write it as 2t I cap plus t square j cap. Because velocity is varying with time, how can you write acceleration as? I can write it as dv bar divided by dt. I'm directly writing it, guys. If you just differentiate this, I'll get 2i cap. I'll get this as 2t j cap. So what will be the force? Force is written as mass times of acceleration. So how much will I get? The mass is already given as 4. So I'll get it as 8i cap plus 8t j cap. So what is the force at t is equal to 2 seconds they are asking. So I'll write it as 8 I cap plus 16 j cap, guys. Clear, everyone? Yes or no? Very direct case again. Velocity is varying with time. So I can write the acceleration as dv bar by dt. From there, we can write the force as m into acceleration, guys. Clear, everyone? Yes or no? I hope it is clear. Right. Next question is very, very important, guys. You see, a balloon of mass 20 kg is moving downward with an acceleration 2.2 meter per second square. What mass delta m has to be removed so that it starts moving up with same acceleration? Basically, this question should be asked from fluids because we talk about viscous force, guys. So let us imagine we have a certain balloon. So where is it moving? It is moving with an acceleration in downward direction. Let us say its mass is m. So what are the forces that are going to act? See, if only weight was acting, it would have accelerated with 10 meter per second square. But because it is accelerating with 2.2 meter per second square, I can come to a conclusion that there will be some retarding force which is going to applied by the air, guys, on the balloon. Now what they are saying, how much mass I need to remove such that it will start moving up now. So what they are saying, this should move up with same acceleration. And in that case, how much mass I need to remove, they are saying. So let us say I have removed delta m mass. So I'll get m minus delta m here. So what are the forces that are going to act, beta? Weight will act. How much will that weight be? M minus delta m into g. And definitely, what will also act? Viscous force will be acting. So in both the cases, you just write the net force equation. In first case, what is the net force equation? Because acceleration is in downward direction, mg minus fv. So I can write ma value will be mg minus fv. So I'll get the viscous force acting as mg minus ma. So I'll get the viscous force as m into g minus a. Okay. Next case, if you write net force, what will I get, beta, in next case? Acceleration is in upward direction. So what will I get the net force in this case now? I'll get it as viscous force minus m minus delta m into g, beta. Right? So what is this now? I can write m minus delta m into a should be equal to, what is viscous force we got? M into g minus a minus of m minus delta m into g, you can write. Clear? So what are we going to get? You can just consider. So I'll get m into a, then they're asking what should be the delta m mass. Okay, minus delta m into a should be equal to mg minus ma minus mg plus delta m into g. So what we can cancel out from this? Plus mg minus mg will get cancelled out. Delta m I will send on the other side, guys. Ma I will send on this side. So what will I get? 2 ma value, you will get it as delta m into g plus delta m into a. So what will I get delta m value as? You will get it as 2 ma divided by this much mass you have to remove, guys. And if you solve for it, you will get it as 2 into, what is the mass given? 20. What is acceleration? 2.2 divided by g value is asked to be taken as 9.8. 9.8 plus 2.2 will be 12, guys. So 2 ones, 2 6 you will get, right? So you will get the delta m value as 44 divided by 6. 7.33 you will get as the answer. So this much mass has to be removed in order to ensure that the balloon which was initially accelerating in downward direction will accelerate in upward direction with the same acceleration. Clear, everyone? Yes or no? The last question, let us see, guys. What they have given, a body of mass 3 kg is launched up a rough inclined plane making an angle of 45 degrees with horizontal. First, it is launched up. What is the coefficient of friction between the body and inclined plane if time of ascent is half of the time of descent, guys? Okay, which is also very important case. 3 kg mass, 45 degrees has been given. Yes or no? A body of mass 3 kg is launched up a rough inclined plane making an angle of 45 degrees with horizontal. What is the coefficient of friction between? So I'll just tell you the difference between ascent and descent here, guys. Right. Inclined plane is given to us during ascent. Ascent means it has to climb up, guys. Let us say it has started with some. So while it is ascending, where will its velocity be? It is going to be in upward direction or not? So relative to the inclined plane, during ascent, it will move in upward direction. So how will friction act, beta? Friction is going to act in this manner. What are the other components that will act? You will have mg cos theta acting in this manner, right? You will also have mg sin theta acting in this manner. And obviously normal reaction, because mg cos theta is applied as the action, so normal reaction will be given. So here in this situation, you see what is the net acceleration in this case? Both mg sin theta and friction will be responsible in giving retardation, guys. So what is friction value? Maximum value, if I take, it is mu times of normal reaction. So what will I get, beta? Mu times of mg cos theta. So here in ascent, this is our ascent case, guys. In ascent or ascend, you can write. So in this situation, what will our retardation be? I will write it as what we can consider mg sin theta plus friction value, which is mu mg cos theta divided by m. So I'll get it as g. If I take common, you'll get it as sin theta plus mu cos theta. Okay, this is during the ascent, guys. Similarly, let us say during descent, beta, right? From the top till the bottom, it has to come. Means length traveled will be same again. This is the situation during descent, or you can write descend also. Now you see, we have a block. Where is it going to move while in its descent? It is going to move in downward direction. So relative to the inclined plane, it is moving in downward direction. How will friction act? It always opposes relative motion, beta. And what is going to act here? We are going to have mg cos theta. In the same manner, what will also act? Another component, or I'll just write velocity to be. Another component will be acting here, which is mg sin theta. So here you have v value. Obviously, mg cos theta is given as normal reaction, sorry, as action. So we will have a normal reaction here. So again, friction value in this case also will be mu times of normal reaction, which I can take it as mu mg cos theta. Imagine, assuming that theta is our angle of inclination, beta. So here in this case, you see, right, during its descent again, right, velocity. So obviously it is moving down. So while it is descending, its speed will increase, guys. So here in this situation, what will our acceleration be? It will be mg sin theta. So your acceleration will be in this direction, beta. So you'll write mg sin theta minus mu mg cos theta divided by m. So acceleration in descent will be g into sin theta minus mu cos theta. So basically we know, initially let us say, so what would be the condition which we can write? Times they have given, guys. So I can use s bar is equal to u bar t plus half a bar t square. In both the cases, s value will be same again. Yes or no? So in general, what I can write? I can write the time of ascent or descent as root over 2s, which is length of the incline divided by acceleration. Clear, all of you? So what they have given, I think they have given time of ascent is, time of descent is half, or what did they give, guys? Time of ascent is half the time of descent they have given. So what we can write in this situation? Time of ascent is given as time of descent divided by 2, or I can write ta square value will be td square divided by 4. So what we can write ta square as? I can write as 2s divided by a, and here you take a dash, guys, just for understanding purpose. And here I can write 1 by 4 into same distance again, 2s divided by a dash. So you can cancel out 2s, 2s. So what will I get a value as? I'll get it as 4 times of a dash, implies g into sine theta plus mu cos theta will be equal to 4g into sine theta minus mu cos theta. So what we can take, g and g will get cancelled out. So eventually, what are we going to get, beta? We're going to get something like this: sine theta plus mu cos theta should be equal to 4 sine theta minus 4 mu cos theta. So I'll get 5 mu cos theta as 3 sine theta. Yes or no? Or we can write mu value as 3 by 5 sine theta divided by cos theta, which I'll get 3 by 5 tan theta. How much is angle of inclination given? If you look at the angle of inclination, I think it is given as 45 degrees, I believe. Yes or no? So tan 45 will be anyhow 1. So I'll get the answer as 3 by 5, which is 0.66. Clear, everyone? So these were the questions from your motion in a, laws of motion, guys. Understood, all of you? So here theta value was given as 45. So as theta is given as 45, you can write mu value as, so as theta value is given as 45 degrees. So what will I get mu value as? You will get it as 3 by 5 times of tan 45, which turns out to be 3 by 5, which is 0.6, guys. Clear, everyone? Understood, all of you? Right, so always remember, in case of descent, the acceleration of the block will be g into sine theta minus mu cos theta. In case of ascent, acceleration will be g into sine theta plus mu cos theta. Understood, all of you? Whether it is in ascent or descent, they are going to travel the same distance, which is the length of the incline. Clear, everyone? Yes or no? So we have discussed, again, I'm not discussing any difficult question, guys. I'm just discussing easy to moderate questions. Okay, I'm not discussing difficult questions at all, because our intention is to do 120. Our intention is not to do 150. For those who are interested in getting more than 150, I'm already sharing assignments to them. Okay, the rest of the assignments also I'll share, guys. The laws of motion I'll share today. Clear, all of you? All the questions of laws of motion clear? Right, so we will move on to work, energy and power, but we will just take a 5-minute break at least, guys. Okay, so you can take an 8-minute break. You can come back by 9:35. Okay, is that clear? Right, by 9:35 you can come back. We will just have a review of work, energy and power. Okay, thank you all. We'll meet soon. Is the board visible? Hello, you want more time or what, guys? पढ़ाने वाला आ गया, पढ़ने वाला नहीं आया, देखो. Right. So maybe for the next whatever time it is, we will just try to give the review of work energy power to whatever extent I can give. I'll try giving, guys. Okay. Right. We'll begin. Right. So laws of motion, work energy, power, system of particles are very, very important, crucial chapters. From these three chapters, you may get around 6 to 8 questions, guys. Right. So almost 24 to 32 marks from these three chapters. On an average, you can take 10 marks from each chapter, guys. Okay. So when we talk about work again, basically you all know what is work. Whenever there is a force which is trying to give some displacement, then we will say work is said to be done. Or in general, we can say it is product of component of force along the displacement and magnitude of displacement. We can basically say that. Right, two things we have. Whenever we have constant force, if we have constant force, then work done will be given as dot product of force and displacement. If we have variable force, then work done will be given as integral of F bar dot ds bar. Or in general, so very basic logic, for constant force, whenever we take constant force, work done will be given as F bar dot S bar. Now displacement can also be given as change in position, guys. F bar dot delta R bar you can write. Right? Similarly, for variable force, in place of using delta, right, what are we going to use? We are going to make use of d. So I'll use integral of F bar dot dr bar from some initial position to some final position. So what are we going to obtain from integration? You all know integration is going to give us area, guys. So what we can do, area covered under which graph, beta? Force versus displacement graph, you can say, or force versus position graph with position or displacement axis will give us work done, guys. With position or displacement axis is going to give us the work done. Now be very careful while calculating the work. The area covered above displacement or position axis should be taken as positive. Area covered below the displacement or position axis should be taken as negative. Now there are two important points to note related to dr bar, guys. Now, always remember, in plane, dr bar will be written as dx I cap plus dy j cap. In space, right, the small position vector dr bar can be written as dx I cap plus dy j cap plus dz k cap, guys. Okay, so I can, that is how, if we just and f bar can be written as, in plane you can write fx I cap plus fy j cap. In space you can write it as fx I cap plus fy j cap plus fz k cap, guys. So that is so because of which we can write work done as integral of fx dx plus integral of fy dy plus integral of fz dz. So from some x initial to x final. If only x-axis there, you will write this. If x-axis and y-axis is there, you will write these two. If x, y, and z are there, then you will write all these three, guys. Okay. So work done will be given as integral f bar dot dr bar. Dr bar can be written as dx I cap plus dy j cap in plane, dx I cap plus dy j cap plus dz k cap in space, guys. Right? So in general, work done can be written as integral fx dx plus integral fy dy plus integral fz dz from some x initial to x final, y initial to y final, z initial to z final. That is the basic logic, guys. Right? And always remember, work is a scalar quantity because it is obtained by performing dot product of two vectors, guys, right? Then we have kinetic energy. Whatever the energy is possessed because of motion will be called as kinetic energy, and it is given as half mv square p square by 2m, or I can write it as p bar dot v bar divided by 2. This is the expression for kinetic energy, half mv square p square by 2m, or p bar dot v bar divided by 2. Now, whenever we talk about forces, we have also certain theorem called as work energy theorem. So, related to work, any doubt, all of you? Constant force is there means directly you do f bar dot s bar, right? And variable force is there means we are going to perform integration. What do we obtain from integration? We are going to get the area, guys. So if force versus displacement graph is given, area covered under force versus displacement graph with the displacement axis or position axis will give us the work done. Area above displacement axis positive, area below displacement axis negative. The energy possessed by the object due to motion will be called as kinetic energy. Its expression will be half mv square or p square divided by 2m, or p bar dot v bar divided by 2. So there is a equation which relates work done and kinetic energy. That theorem is called as work energy theorem. And what is it stating, guys? The total work done or work done by all forces will be equal to change in kinetic energy of the system. So I can include external forces as well as internal forces. I can also include the conservative forces as well as non-conservative forces, guys. So what does work energy theorem states? Work done by all forces acting in the system will be change in kinetic energy of the system, guys. Clear, all of you? And usually internal forces are going to cancel out each other, so they will not do any work, guys. Work done by internal forces usually will be zero again, usually in most of the cases. Okay, clear, everyone? So we'll not talk about work done by spring force. Okay, again, work done basically will be given as minus delta u here. So we have elastic potential energy, so I cannot tell it just now. Okay, so we will not focus on work done by spring force as of now, guys. Right. So let us see some very basic points again. So work done as well as kinetic energy, they are going to depend on frame of reference, guys. Okay, so all these points are not that much essential again from basic logic. These are not that much essential, guys. Okay. Next, we have something called as potential energy. What is potential energy basically, right? So whenever we have energy possessed in the object by virtue of the position, guys, by virtue of motion, kinetic energy, by virtue of position, it will be potential energy, guys. Can you define potential energy at a point? No, you cannot define potential energy at a point, right? You can define potential energy at a point only with respect to a certain level or a certain reference called as zero potential energy level, guys. However, you cannot define potential energy at a point. If you are defining potential energy at a point, it means that point will have so and so amount of potential energy if or with respect to some zero potential energy level. Change in potential energy can always be defined. And always remember, whenever we are defining potential energy can be defined only in conservative field. Means only when conservative forces are acting. Okay. So if some expression of potential energy is given, it means potential energy is being defined. When can potential energy be defined? Only when conservative forces or only when conservative fields are present, guys. So whenever we talk about potential energy, you cannot define potential energy at a point. If we are defining potential energy at a point, it has to be with respect to some zero potential energy level. Change in potential energy can be defined. Potential energy can be defined only in conservative fields. So if an expression for potential energy is given, then automatically I can consider that the forces acting are conservative. We will see what are the difference between conservative and non-conservative forces, right? We have two types of potential energy again, gravitational as well as elastic potential energy. Basically, gravitational potential energy will be by virtue of height. Elastic potential energy will be by virtue of deformation, guys. Okay. So whenever a point is above zero potential energy level, right, will have positive potential energy. If the point is below potential energy, zero potential energy level, then it will have negative potential energy. However, irrespective of whatever zero potential energy you may take, guys, change in potential energy between two fixed points will always remain constant. So suppose what will be the expression for potential energy? If a mass m is at a displacement h or is it a height h above zero potential energy level, then I can write mgh will be the expression for gravitational potential energy. Clear all of you? Yes or no? Then we also have elastic potential energy, right? It is the energy possessed in the spring, guys. Usually it will be due to deformation. And what is the elastic potential energy expression given as? It will be given as half k x square, or I can write it as half into kx into x you can write, which will be nothing but spring force into deformation, or into k by k you can do, guys. We can write it as half into fs square divided by k, right? These are very important again. If spring forces are same, right, what would be the ratio of potential energy, they will ask you. So for same spring force, potential energy will be directly proportional to deformation or inversely proportional to spring constant. So whether you are, so in natural position basically x value will be 0, guys. For elongation x value will be positive. For compression x value will be taken as negative. So irrespective of whether you have elongation or compression, elastic potential energy stored will always be positive only, guys. Elastic potential energy stored will always be positive. Clear? By virtue of height, gravitational potential energy. By virtue of deformation, elastic potential energy. Elastic potential energy will always be positive. Half kx square, half into fs into x, or half into fs square divided by k. What is fs here? Fs is the spring force, which we have already studied in laws of motion. It will always act opposite to the deformation, guys. If I take only the magnitude, then we can take it as k times of x. Clear, everyone? Please remember the expressions. By virtue of motion, kinetic energy, half mv square, p square by 2m, p bar dot v bar divided by 2. By virtue of position, means height and deformation. By virtue of height, gravitational potential energy, basic expression is mgh. Above zero potential energy level, positive. Below zero potential energy level, negative. Right? You cannot define potential energy, guys. You can only define its change. In the same manner, elastic potential energy will be given as half into k into x square, will always be positive, whether you are talking about your elongation or your compression. Now, as I said, potential energy can be defined only in conservative field or only when conservative forces are acting. Let us try to see what is the relation between conservative forces and non-conservative forces. How to basically identify, guys, right? So when we talk about conservative and non-conservative forces, we can identify majorly by four cases, guys. We have conservative and non-conservative forces. So how we can identify? We can identify them based on these four characteristics. There will always be a relation between conservative forces and potential energy. So conservative forces will always be given as minus of du divided by dr r cap. However, there is no relation between non-conservative forces and potential energy. And what is the significance of minus sign here? It indicates that conservative forces will always act in the direction of decreasing potential energy, guys. Similarly, if conservative forces are acting, right, work done by conservative forces is reversible. It means there will not be any losses. Whereas work done by non-conservative forces will be irreversible, guys. There will be losses again. Similarly, when conservative forces are acting, if work done by the force in different paths is same, then such force will be conservative force. Work done by conservative force will be path independent, whereas work done by non-conservative forces will be path dependent. So if I take only one force and I'm taking the object in three different paths, in all paths, if the work is same, then that force will be conservative. In all paths, if the work is different, then it will be a non-conservative force. And also remember, if we are taking a round trip, work done by conservative forces in round trip will basically be 0. And whereas non-conservative forces, work done in round trip need not necessarily be 0. These are the four ways in which we can identify whether the given force is conservative or non-conservative. So there will always be a relation between conservative forces and potential energy, which is given as minus of du divided by dr r cap, or du by dx I cap, du by dy j cap, du by dz k cap. However, there is no relation between conservative and non-conservative forces. Work done by conservative forces will be reversible. Work done by non-conservative forces will be irreversible. Work done by conservative forces doesn't depend on path. Work done by non-conservative forces will depend on path. Work done by conservative forces in round trip will be zero, whereas by non-conservative forces, they may not necessarily be zero, guys. Clear, all of you? Yes or no? That is how we can identify whether the given force is conservative or not. Okay, right? Basic things I have told you again. Now, what is major important case that you should be aware about? Usually, in case of your, suppose, let us say I am lifting some object, guys. So, whenever I am lifting some object, am I doing work against gravity or not? So, gravity happens to be conservative force. So, two very important things we have, guys, which are very helpful in solving questions. Work done by conservative forces. Whenever we talk about work done by conservative forces, it will be minus delta u beta, means u initial minus u final. Likewise, if you are doing work against conservative forces, it means they will be work done by external agent. Always remember, guys, if there is no change in kinetic energy, work done by external agent will be given as delta u, which is u final minus u initial. These two are very, very important cases. Work done by conservative forces minus delta u, work done by external agent will be delta u. Now, we have something called as equilibrium. In the last, I think yesterday session, I have told you about equilibrium. What is the meaning of equilibrium, guys? Net force, net external force acting should be zero. Suppose, when can you define potential energy? Only in conservative fields, right? So, what we can say, at equilibrium positions, force is zero. If force is zero, I can write minus of du by dx will also be zero. So depending on whether potential energy is minimum or maximum or constant, we will have three types of, again, when I say equilibrium, I have told you till work energy power, it will be translation equilibrium only, guys. Right. So we have three types of translation equilibrium. What are those? They are stable equilibrium, unstable equilibrium, and neutral equilibrium. Right? For all these, for stable equilibrium, what is the condition? Potential energy should be minimum. For unstable equilibrium, beta, potential energy is maximum. Right? For neutral equilibrium, we can consider potential energy is constant. You can take it as zero also, guys. You can take it as what? Zero also. Now, for any type of equilibrium, very basic thing, what is there? Force should be zero. Here also, force should be zero. Here also, force should be zero. Force is zero means, again, du divided by dr or du divided by dx. If you take only one dimension, guys, du divided by dx should be zero. Here also, du divided by dx should be zero. Here also, du divided by dx should be zero. So what is the meaning of differentiation here? Will it give slope or not? So at any equilibrium, always remember, slope of potential energy versus position graph will be zero. So where can you have equilibrium? At all those points where force is zero, where slope of potential energy versus position graph is zero. At all these points we'll have equilibrium. Now we have to be little bit specific, guys. Potential energy is minimum. For minima, maxima again. For minima, second derivative should be positive, guys. That is the reason you see d square u divided by dx square should be what? Positive. Again, for maxima, second derivative should be negative. If you have constant value, anyhow you can write d square u by dx square should be equal to 0. Now we have a relation between force. I can write force as minus du by dx. If I differentiate on both sides again, what will I get? I'll get df by dx as minus of d square u by dx square, guys. So if d square u by dx square is positive, what will df by dx be? df by dx will be negative. If d square u by dx square is negative, df by dx will be positive. If d square u by dx square is 0, df by dx will also be 0. So how to identify stable equilibrium? Again, whether it is stable, unstable or neutral, force will be 0. Suppose if force versus position graph is given, at whichever point slope of force versus position graph is negative, at that point you will have stable equilibrium. At whichever point slope of force and position graph is positive, at that point you will have unstable equilibrium. At whichever point slope of force versus position graph is 0, at that point you will have neutral. Two conditions you need to remember: force should be 0, slope of force versus position graph negative, stable equilibrium. Force is 0, slope of force versus position graph positive, unstable equilibrium. Force 0, slope of force and position graph 0, neutral equilibrium. Again, how do you define in terms of potential energy? Slope of potential energy versus position graph 0 for all stable, unstable, neutral equilibrium. For d square u by dx square positive for stable, d square u by dx square negative for unstable, d square u by dx square should be 0 for neutral equilibrium. Clear all of you? Yes or no, everyone? How to identify conservative, non-conservative forces, different types of equilibrium, how to calculate work done, what is work energy theorem. These things clear, everyone? Yes or no? Then we have something called as law of conservation of mechanical energy. Potential energy also, I think, clear. Right, which are conservative forces, guys? Again, gravitational force you take, spring force you take, electromagnetic force, spring force, anyhow, electromagnetic force. These are conservative forces again. And what will be work done by conservative forces? It will always be minus of delta U, guys. Okay, based on conservative forces and potential energy relation, we have three types of equilibrium again. What are those? Stable, unstable, and neutral. How to identify stable, unstable, and neutral? Clear? Yes or no, everyone? Right? If force graph is given, how to identify? I've told you. Potential energy graph is given, how to identify? Also, I've told you, guys. Now, what is principle of mechanical energy or conservation of mechanical energy? Basically, if you have only conservative forces acting on the system, then I can say mechanical energy will remain conserved. What is meaning of mechanical energy? It is sum of kinetic energy as well as potential energy of the system, guys. Two cases are there. If forces are conservative, can I apply conservation of mechanical energy? Yes, I can say total mechanical energy will remain constant. But what if forces are non-conservative also? If non-conservative forces are also acting, if only conservative forces are acting, I will say energy will remain constant. If non-conservative forces are also acting, can you conserve mechanical energy? See here statement, do you see? When only conservative forces are working or acting on the system, mechanical energy will remain constant. But what if non-conservative forces are acting? Will mechanical energy be constant? Again, when non-conservative forces are acting, I will say yes, mechanical energy will be constant. I will also say no, mechanical energy will not be constant. So if non-conservative forces are also acting, we can either conserve or we may not conserve. When can we conserve? Always remember, if there is no work done by non-conservative force. So if work done by non-conservative force is 0, then I can conserve the mechanical energy. However, if work done by non-conservative forces, if it is non-zero, guys, then I cannot conserve the mechanical energy. If non-conservative forces are doing any work, it means there are losses. You cannot conserve mechanical energy. If non-conservative forces are not doing any work, it means there are no losses. You can conserve the mechanical energy of the system. Is that clear, everyone? Yes or no? I hope it is clear when to conserve. We will see the applications in tomorrow's session. So we can conserve mechanical energy only if conservative forces are acting. We can also conserve mechanical energy if non-conservative forces are also acting. When can we conserve? If work done by non-conservative forces is zero. Always remember, in next chapter we focus on this point, guys. Work done by friction in case of pure rolling, guys, is zero. Friction is a non-conservative force. And please remember, work done by friction in pure rolling will be zero. So there is again one more property. Friction can either do a positive work, a negative work, or zero work. Right? Work can again either be positive, negative, or zero. Suppose if angle between force and displacement is 90, then work done will be zero. If force and displacement are in same direction, positive. If force and displacement are in opposite direction, negative. So work can either be positive, negative, or zero. Friction can again do either positive work, negative work, or zero work. In which case, zero work by friction, work done by friction in pure rolling will be zero, guys. Clear, all of you? Then we have power. We know power is rate of doing work, and as I said you, whenever a term rate comes into picture, what I'm going to make use of? I'm going to make use of differentiation. So rate of doing work will be called as our power, guys. And if I take constant force, then power can be represented as dot product of force and velocity, guys. It can be represented as dot product of force and velocity. Majorly you will get questions based on power also again. Okay, we have some applications again, guys, which we will see in tomorrow's session with the help of numericals again, right? So we'll see these in tomorrow's case, guys. The applications part I'll see in tomorrow's case. So I've already told some applications again. Spring constants are same, spring forces are same. What will be expression for potential energy and all. So these things anyhow you can identify, guys. Then we move on to collisions. Now, whenever we talk about collision, whether we consider one dimension collision or two dimension collision, three points are very important, guys. First will be application of conservation of linear momentum, right? Whatever is the momentum before collision, same will be the momentum after collision, right? Writing the expression for coefficient of restitution. What is coefficient of restitution? Again, it is given as the ratio of velocity of separation to the velocity of approach. Basically, theoretically, coefficient of restitution will lie between 0 and 1. But practically, it will lie between 0 and 0.5 only, guys. And we have loss in kinetic energy formula. Half m1 m2 divided by m1 plus m2 u1 minus u2 whole square into 1 minus e square. Right? In any type of collision, whether it is one dimension, two dimension collision, you will conserve the linear momentum. Initial momentum should be equal to final momentum of the system. And you will write equation for coefficient of restitution. Coefficient of restitution is given as ratio of velocity of separation to the velocity of approach. You see, here I am assuming u1 to be greater than u2. So u1 will come and hit u2. So I can say m1 is approaching m2 with what velocity? u1 minus u2. After collision, I want to limit the number of collisions to only one, guys. So I'll assume V2 is greater than V1. So if V2 is greater than V1, M2 is going to get separated from M1. With what velocity? V2 minus V1. These two you should remember again. You should conserve linear momentum and you should write the equation for coefficient of restitution. And loss in kinetic energy will be half M1 M2 divided by M1 plus M2 into U1 minus U2 whole square into 1 minus E square. Theoretically, coefficient of restitution will lie between 0 and 1. Practically, it will lie between 0 and 0.5, guys. Clear, everyone? Yes or no? We have two major cases. One will be elastic collision. For elastic collision, coefficient of restitution value will be 1, guys. And we can also find the final velocities. If initial velocities are given, coefficient of restitutions are given, we can find final velocities. V1 bar will be given as m1 minus em2 divided by m1 plus m2 into u1 bar plus m2 into 1 plus e divided by m1 plus. If you want to remember this, you can remember, guys. Similarly, the second object's velocity will be given as m1 into 1 plus e divided by m1 plus m2 into u1 bar plus m2 minus em1 divided by m1 plus m2 into u2 bar. These are the final velocities. Okay. In elastic collision, apart from conserving the linear momentum, we can also conserve the kinetic energy, guys. Will kinetic energy remain constant at all instants? No. Right? Kinetic energy cannot be conserved during collision, guys. During collision, it cannot be conserved. It will be conserved before and after collision. During collision, it cannot be conserved, guys. So for elastic collision, E value will be 1. There is also one more very important collision called as perfectly inelastic collision. For perfectly inelastic collision, coefficient of restitution value will be 0. Now, what is the meaning of perfectly inelastic collision? That particular collision wherein which after collision, both the objects will move together or both will move with a common velocity, guys. That will be your perfectly inelastic collision. What is that collision? After collision, both the objects will move together or will move as one combined mass. Okay, in that case, E value will be 0. Clear, all of you? There are few cases in collision again. What are those cases? I'll tell you. Suppose if I assume, again, I'll just write it over here. If m1 mass, let us say m1 is going and colliding with m2 in the diagram. If this mass is very much more than m2, then motion of m1 mass will not get affected, guys. So what is the meaning here? v1 bar will move with u1 bar only after collision also. So m1 was going and hitting m2. So if m1 is much more heavier compared to m2, motion of m1 will not get affected, guys. Clear, all of you? Yes or no, everyone? Right, see, you can consider, and anyhow, you can find the value of m2 again, which will be 2u1 minus u2 here, but you can use the formulas and you cannot remember everything, guys. You can use the formulas and you can find it out. Okay. So always remember, whenever the mass which is going and colliding is very much heavier, its motion will not get affected. Right? Also, one more case. Suppose if identical means masses are same, collide elastically. If identical objects collide elastically, let us say they are colliding elastically in one dimension, guys. So whenever identical objects collide elastically, after collision, their velocities will get interchanged, guys. Means first object will move with initial velocity of second object and second object will move with initial velocity of first object. Very important case. If identical objects collide elastically in one dimension, velocities are going to get interchanged, guys. Okay. In the same manner, always remember, if you have an elastic wall, let us say if the object is hitting an elastic wall with speed u, then it will again rebound with same speed. However, if it is hitting with speed u, for inelastic wall, it will be rebounding with speed eu, guys. Okay. Here, everyone. Right. So all these cases are not that much necessary. Right. As I've said you before, momentum in which direction will be conserved in this case, you see? Momentum along x direction will be conserved. Why? Because x component of velocities will not be responsible for collision, guys. These two are very important cases again. And one more case, if I can tell you, suppose in one dimension, if they are colliding elastically, velocities will get interchanged. However, if identical objects collide elastically, obliquely, guys. What do I mean by obliquely again? In two dimension. In such a way that, let us say, in such a way that second object is at rest. Then what will happen? After collision, they move perpendicular to each other. After collision, they move in mutually perpendicular directions, you can say. In mutually perpendicular directions. Clear, all of you? Identical objects colliding elastically in one dimension, velocity is interchanged. Identical objects colliding elastically in two dimension, after collision, they will move in mutually perpendicular directions. Clear, everyone, all of you? Yes or no? Is that clear, everyone?
Yes, sir.
And this is one of the case. I cannot prove all these cases now, guys. But basically, remember, whenever object is dropped from a certain height onto an inelastic floor, after first collision, second collision, third collision, fourth collision, fifth collision, the speed after nth collision will become e power n times of root over 2g h naught. And after first collision, it will reach e square into h naught. After second collision, e power 4. After third collision, e power 6. So after nth collision, the height attained will be e power 2n times of h naught. The total distance covered, right, during this particular process before it comes to rest will be given as h naught into 1 plus e square divided by 1 minus e square. And the time for which the object will travel before it comes to rest will be root over 2h naught by g 1 plus e divided by 1 minus e. The average force exerted will be equal to weight of the object, guys, and displacement, to be precise, displacement will be minus h, guys. It is not h naught, it will be minus h naught. Why? Because, see, if you are dropping an object, you take a ball, you are dropping it from a certain height. After collision, will it come back to the same height? No. Why? Because in reality, there is no surface which is perfectly elastic. So what will happen when you drop? It will come to a less height. Then again, some more less height, some more less height, some more less height, some more less height, some more less height. Finally, it will stop there only. Yes or no, all of you? So what is happening? But why did I take separately here? Just to differentiate between the number of collisions. What is happening after first collision? What is happening after second collision? Just to show the motion after consecutive collisions, I have shown it like this. But this whole process will take place at one point only, guys, with very minute horizontal displacements, right? So initial position is this, final position is this. So what will displacement be? Minus h naught. These formulas are very important, guys. Height attained after nth collision, e power 2n times of h naught. Speed after nth collision, e power n times of root over 2gh. The total distance traveled, h into 1 plus e square divided by 1 minus e square. The total time for which it will travel, root over 2h by g into 1 plus e divided by 1 minus e. Average force will be mg, and when it is stopping, the displacement will be minus h naught, guys. Clear, all of you? Oblique collision, I have told you just now, right? If two objects are colliding elastically, obliquely, in such a way that one of the object is at rest, then after collision, they will move perpendicular to each other. Clear, everyone? So we have some applications of collisions also, which we will try to focus on while we are solving the questions. Anyhow, I'll share all these with you people, guys. The applications we'll focus while solving questions again. Then we have motion in a vertical circle. Always remember, motion in a vertical circle is a case of non-uniform circular motion, guys. It is a case of non-uniform circular motion. Why? Because speed everywhere will be keeping on changing, right? Speed will keep on changing, guys. So here, this will include circular motion equation. Motion in a vertical circle will include circular motion as well as conservation of mechanical energy, guys. As well as conservation of mechanical energy. This also we will study while solving problems in detail. Now, this will be the lowest point. Always remember, tension will be highest or maximum at lowest point. Tension is what? Maximum at lowest point. Similarly, at highest point, beta, tension will be minimum. Again, 2019, you got a question based on this. So where will it be more likely to break? It will be likely to break at lowest position because tension will be maximum at the lowest position, right? So this is lowest position. You can consider this is horizontal position. This is highest position. This is some arbitrary position, guys, right? So always remember what will be, whatever may be the speed at the lowest position, what will be true always. Always remember, tangential force is g sine theta always, right? Centripetal force, again, at any arbitrary point if I take, right, it will be given as centripetal acceleration will be given as speed at that point square divided by radius, guys. Now what will be true always is, I am writing here, guys, tension at lowest position minus tension at highest position will always be equal to 6 mg, and tension at lowest position minus tension at any point, it will be given as 3 mg into 1 minus cos theta. These will always be true. Tension at lowest, tension at highest, 6 mg. Tension at lowest minus tension at any arbitrary point, 3 mg into 1 minus cos theta. These will always be true, guys. Okay. Whatever may be the speed given at the lowest position, these two will always be true. Tension at highest point will always be minimum. Tension at lowest point will always be maximum. Three conditions which you have. If the speed given at lowest point is less than root over 2gl, if we are giving equal to root 2gl, what will happen? This point is fixed, guys. When you are giving equal to root 2gl, it will just reach horizontal position. Okay. If we are giving more than root 2gl, it will cross horizontal position. But in order to reach highest position, you need to give at least a speed of root 5gl at the bottom. So when you are giving less than or equal to root 2gl, what will happen? Object will oscillate between this point and this point. And how much will be the maximum angular displacement? 90 degrees, guys. It will object about the lowest position with a maximum angular displacement of 90 degrees. If the speed given at lowest point is lying between root 2gl and root 5gl, if you are giving more than root 2gl, it will cross this position. But if you are giving less than root 5gl, it will not be able to cross this position. So somewhere in between these 2 points or these 2 points, it will leave the trajectory, guys. So as you can see, object leaves the circular path somewhere between m dash and h. If you are giving a speed more than root 5gl or equal to root 5gl, then it will be completing circular motion, guys. Clear all of you? It will complete vertical circle. Understood, everyone? When you are giving a speed root 2gl, it will reach horizontal position. Its velocity becomes 0 here. When you are giving more than root 2gl, it will be crossing m dash, but it will not cross h. In order to cross h or reach h, you should give at least root 5gl speed at the bottom. So whatever speed you are giving at the bottom, these will always remain true. Tension at lowest minus tension at highest will be 6 mg. Tension at lowest minus tension at any arbitrary position will be 3 mg into 1 minus cos theta. So what is vertical circular motion? It is just concept of circular motion as well as mechanical energy conservation combined concept, guys. Clear, everyone? So the applications of work energy power we will be discussing in tomorrow's class. Understood, all of you? Please remember these cases. Less than root 2gl or equal to root 2gl, it will oscillate. More than root 2gl, it will cross this point. But if speed is less than root 5gl, it will not be able to cross h. So somewhere between m dash and h, it will leave the circular motion. If it is equal to root 5gl, it will just reach h. And if it is more than root 5gl, it will cross h, guys. Okay. These cases you should be aware in vertical circular motion. Clear, all of you? The application parts, whatever are given, we can discuss these applications with the help of numericals in tomorrow's class. So tomorrow completely we will be focusing on work energy power. By tomorrow we will complete work energy power also. So maybe I'll share the test paper if possible, right, by today night. If not, by tomorrow morning I will be sharing it, guys. Clear, everyone?
Sir.
Yes, sir.
So could you explain that how did we got the relation of slope of force versus position?
Slope of force.
Versus position.
This one, no.
Yes, sir.
Do you want to know how we got this relation?
Yes, sir.
So if you differentiate it, what will I get? df by dx, I'll get it as minus of d square u by dx square. What is stable equilibrium position? That position where potential energy is minimum. For minima, second derivative will be positive. So d square u by dx square is positive. If d square u by dx square is positive, what will df by dx be? Negative. So what is the meaning of differentiation? What will differentiation give us? Slope. The slope of force versus position graph, wherever is negative and force should be zero, there you will obtain stable equilibrium. Similarly goes with unstable. Wherever force is zero and slope of force versus position graph is positive, there you will obtain unstable equilibrium. Wherever force is zero and slope of force versus position is also zero, you will get neutral equilibrium. Clear?
Yes, sir.
Right. So that would be from my end for today, guys. Okay, all the applications part we will cover with the help of numericals that will be discussed in tomorrow's class. Tomorrow our focus will be on completing the questions of work, energy, power. Friday and Saturday we can discuss system of particles. Sunday we will do both gravitation and units and measurement, guys. Okay, so that's it from my end for today. We'll meet in tomorrow's class. Till then, take care everyone. Thank you all. Good night all of you.
Sir,
Yes, sir.
sir, do we have exam today?
I'll share the paper today. You can write it till tomorrow.